from, yeah. Okay, so today I'd like to give you kind of an overview of why it's interesting to study gesture. So what I study is gesture that people produce while they are talking or thinking. And I'd like to convince you that, if you are interested in language and or thought, you should be interested in gesture as well. And so we produce gestures spontaneously when we communicate with language, but also I will show you some video clips. When we silently think, sometimes we do move our hands to represent what we are thinking about spontaneously with our hands. And I'm going to talk about both types of gestures today. And the gestures are interesting because gestures can be seen as a window into the speaker's mind. And because gestures are representational actions. So we make hand movements for various reasons, for practical reasons. So this would be a practical action to drink. But gesture is a representational action. The purpose is to represent an idea. And so by looking at carefully what gesture does to our thinking, we can examine how our body movement can influence cognition. And also by looking at carefully how language and gesture sort of influence each other, you can see that our linguistic communication is really inherently multimodal. And probably, some of you have been, in the field of gesture research for a long time, so you probably know what I am talking about. But some of us probably haven't really thought about gesture as a research topic. So I'd like to show you some examples of type of gestures that I'm very interested in. And so I'm going to show you a video clip of somebody who describes an animated cartoon. And the task was to please, tell a story about the cartoon you saw. We didn't instruct any, we didn't give them anything, we didn't say anything about gesture, but the person spontaneously produced gesture. So first I will show you the animated cartoon that this person saw. Sound is not in.
So we need to put your sound on and mute the room.
Okay. Yes.
Did you mute the room?
Okay.
Right.
And then okay, so they pan out of that, and then it goes to the bird is on the windowsill, up, on the windowsill again, and he's, by that same drain pipe he was climbing up before, and he pulls a box of wood, and then he gets like a long plank of wood and puts that on top of the box, and then he gets this, one of those like big weights, those just a big weight that they always carry around in those stupid cartoons. And so he gets on one side and he throws the weight on the other side to spring him up to get the bird, and he grabs the bird and he goes back down and lands on the thing, and then he runs off. But as he's running with the bird in his hand, the thing that was up in the air, the weight, comes down and crashes on him, and the bird gets away. Okay, so
So that. So those are examples of a gesture about like a spatial information, action information. And I'd like to give you examples of gestures that represent abstract ideas, because gestures are not just about movement and action. And this is an experiment in which people are asked to describe the meaning of that phrase, disclose something confidential. And you will see that this person is going to metaphorically represent this abstract concept using his hands. And then you will see two types of metaphors. So for example, information as a manipulable object. So he's going to do a gesture with a kind of hand. I don't know whether people can see this, like a hand like this, as if to hold a piece of information in the hand. And also you will see hand moving forward away from the body, which represents movement of information away from self. So I'm going to show you this.
To disclose something confidential is to tell people something that.
Oops.
To disclose something confidential is to tell people something that is supposed to be a secret that you're supposed to keep to yourself, and just share it with others is to disclose something confidential.
Something, and then telling was represented as movement away from body. So so gestures can be seen when so maybe I should mute myself, sorry, in the Zoom. Right. So right. So these are the type of phenomena that I'm interested in, and when we think about gesture relationship to thinking and speaking, it's useful to think about distinguish mechanism and function. And in terms of gesture's function, there are two kinds of functions. Communicative function, so gesture can convey information to you. But also gesture has self-oriented or cognitive function. By producing gesture, this body movement is changing the mental representation in my own mind. And in today's talk, I'm going to, in terms of function, I'm going to talk about self-oriented cognitive function of gesture. And to kind of illustrate, the distinction between mechanism and function. So mechanisms is the process that generates gesture. And then function is a consequence of gesture. So once you produce gesture, what kind of cognitive or communicative consequence these gestures have. And I'm going to talk about both today. And right. And I think it's really important to have a kind of integrated theory of the mechanism and function. I think these theories of mechanism and function, people tend to kind of write different papers, separate papers, I think. But I think it's important that the theory of mechanism and theory of function are consistent with each other. So first, mechanism. So this is the mechanism that we have proposed. Me and my colleague Ozyurek at Max Planck Institute. So this is a very busy slide, so I'm going to sort of walk you through it. So the first thing is that the right-hand side is a sort of classic psycholinguistic model for speech production. So at the very bottom, you see speech. So that's the output. And at the very top, you see working memory. So that's where you're activating information that might be relevant for you. And then message generator in the middle is where you generate proposition, the meaning that you want to convey to other people. And this message generation depends on, the discourse model, what you have just talked about, what the other person talked about. And then communication planner is, sort of generates overall communicative intention. And then that, generates a message which gets linguistically formulated. So, choosing the right words for the idea that you want to convey, putting together a sentence structure. So that's what formulator does, and that becomes speech. So that's a kind of a classic psycholinguistic model of speech production. And right, so discourse model, these are, these three red boxes will feed into the generation of the message, which gets formulated and then becomes speech. And on the left-hand side, what you see is something equivalent for gesture. And so action generator is the what generates the idea for action, what action to produce. And the key idea, so when you're talking about the cartoon, you activate spatio-motoric information about the cartoon, which is fed to the action generator that will generate the right kind of movement, hand movement, to represent the idea that you want to show. But also action generator, crucially, produces not only gestures, but also practical actions, your interaction with the world, with the environment, like holding a glass to drink. That kind of information is also provided by the right. So action generator is a general purpose, action generator, which does gesture, but also practical action. So that's, that's okay. And another important feature is that there is a kind of a double arrow between formulator and message generator, and then message generator to the action generator. And so what this means is that the linguistic formulation, information about linguistic formulation actually informs what kind of action you will generate. So those are kind of key features of the model. So, two key features: gestures generate from the general purpose action generator, and there is a link, so outside of the speech production process proper, and also how you are formulating speech can actually influence what kind of gesture you would produce. So these are two key features of this proposal, and so I'd like to present, one piece of evidence for each of the key features. The first, the action generator for both gesture and practical actions. And so if gestures are created in a general purpose sort of mechanism, then gestures should exhibit properties of practical actions, like a drinking, water from a cup. And oops. And in particular, I'm interested in, so we asked the question of whether gesture production is affected by the affordance of referent objects. So affordance is a kind of technical term in psychology, which means the invitation to produce a particular action. So this glass has a affordance for grasping. So this shape invites me to take this action. And so we are interested in whether gesture is affected by object affordances. So so in this experiment, participants were asked to describe how to rotate the mug on the left-hand side so that it's in the same position as the mug on the right-hand side. The typical participant would say for this kind of stimulus, something like, oh, you rotate the mug 45 degrees to the right, something like this. And people still spontaneously produce gesture in the description. And whether or not mugs afforded touching or not. So the mugs on the left is what we call the smooth mug condition. And the crucial condition is spiky mug conditions, where mugs do not invite you to hold it. Yeah. But in terms of communication, it's exactly the same task. For the right-hand display, you would say the same thing, 45 degrees to the right. Yeah. So communicative demand is the same, but what's different is whether or not these stimuli invite you to actually act on them. And what we find is that the people produce more gestures for the smooth mug than the spiky mug. So for this graph, y-axis is the number of gestures produced per minute of speaking. And you can see that the smooth mug elicits spontaneously more gestures. So this indicates that the gestures are also, so gesture is like a simulated action on the imaginary objects, here in the case, the mugs that you see on the computer screen. And oops. Yeah. So this shows that so this is evidence that the gestures are generated from a general purpose action generator, which is outside of the speech production process. So that's evidence for one feature of the mechanism that we're proposing. And next, I'd like to talk about another important feature of the mechanism that we're proposing. So speech to gesture influence. And so speech shapes gesture, essentially. And especially we are interested in grammatical structure of the sentences that people are producing and causal packaging of information. I will tell you what that means in a minute. So so we are interested in how people gesture about manner and path in motion events. And for example, if you're describing this kind of event, a cat has a bowling ball inside his stomach, and he's rolling down the street. And here, rolling is the manner of movement, and path or directionality, downward directionality is the path. And if you ask speakers of different languages to describe this kind of scene, they use different kind of grammatical structure, which I will illustrate in the next slide. And so if you're speaking English, you say something like he rolls down the street. And I highlighted the verb in red. So roll represents the encodes the manner, down encodes the path of the movement. But if you're speaking Japanese or Turkish, you need more complex grammatical structure. So for example, this is Japanese, korogatte saka o kudaru. And you need two verbs, one verb for rolling and another verb for descending. And if you're speaking Turkish, it's almost word for word translation from Japanese. Very similar grammatical structure. So these sentences express the same information, but from psycholinguistic viewpoint, these two sentences have processed quite differently. So there is quite a good evidence that the speech processing unit for speech production is a clause. Clause is the grammatical unit that's controlled by a verb. So So if you're speaking Japanese, there are two clauses. One is about rolling, and the other one is descending the slope. And so you need like a 2 units of processing, 2 cycles of processing cycles for speech production if you speak in Japanese and Turkish. And but if you're speaking English, you need just 1 processing cycle to express mana and path. And we hypothesized that the gesture and speech are linked at this conceptual planning level where you decide, okay, in the next processing cycle, I'm going to express this information. Okay, in the next processing cycle, I'm going to express that information. And if that's the case, then the gesture should look different in those languages. And so we looked at how gestures depict this event, and we can observe in this kind of a event 3 types of gestures. One is a gesture that only express mana, like rolling, and another type of gesture is path gesture, which represents the movement from point A to point B. And then third one is mana path conflated gesture, where mana and path are represented simultaneously. And basically what we found was that the English speakers predominantly use mana path conflated gestures. So they can plan mana, they can plan vocalization of mana and path in a single processing cycle. And, and then gesture also express mana and path in a single movement. But for Japanese and Turkish speakers, you see significantly more mana-only gesture and path-only gesture because their language production system is processing, mana first and then path. And I'm going to skip all the quantitative results and show you 3 video examples to illustrate the key finding. So I have to go back to Zoom. Sorry, to turn up the volume. Yeah. So the typical English speaker who says he rolls down a street into a bowling alley. So single clause, very compact expression of mana and path, and she's going to make a single gesture to produce express mana and path.
He rolls down a street into a bowling alley. He rolls down a street into a bowling alley.
And here's a Japanese speaker who uses 2 clauses to express mana and path. Somehow it rotates like a ball, it rolls, it descends.
なんか回転しながらボールみたいに転がり落ちてやって
One more time.
なんか回転しながらボールみたいに転がり落ちてやって
Next Turkish speaker, again 2 clause description.
유아르는 기죠.
And then gesture also separate mana and path.
유아르는 기죠.
Okay. So this I'm gonna go back. So this study showed that the gesture production system is actually sensitive to the grammatical formulation of the ideas, and that supports the idea that okay. So these two studies combined sort of support the key feature of this model. One is that these gestures are generated outside of the speech production process proper. It's a general purpose action generator, and the linguistic formulation informs what kind of gesture to produce. So these are like two sort of examples of studies that support a particular model of the mechanism that produces gesture. And I'd like to tell you a few studies relating to the function of gesture, especially cognitive function of gesture. And right. So when we think about action and function of gesture, we're given a claim about the mechanism in which speech and gesture talk to each other at the conceptual planning level. So first of all, gesture is generated by general purpose action generator. So that means gesture should also be produced when you're thinking, not just when you're speaking. And also, it should have the same function for speech accompanying gesture and what we call co-thought gesture, thinking accompanying gesture. And the conceptual level linkage between gesture and speaking means that the gesture can influence conceptualization for speaking in general. So our proposal is that the gesture has four cognitive functions. Gesture can activate, manipulate, package, and explore spatio-motoric representations for thinking and speaking. And spatio-motoric representations can be, another way to say it is like imagery, imagery of something moving or somebody acting in a particular way, moving their body, moving the body in a particular way. And the gesture has an ability to activate that kind of imagery or manipulate that imagery when necessary, or packages imagery in the right sort of way and explores ideas through imagery. And I'm going to talk about like four studies quickly to talk about what kind of evidence we have for that. And another sort of important feature of gesture is that the gesture representation is highly schematic. So cartoon has lots and lots of information, but when people depict events with a gesture, it's a highly schematic representation. It's almost like a line drawing, simple line drawing in the air. And so in gesture, information is reduced to essentials. And I think that has some kind of processing advantage because it's a very lightweight representation that can be activated without much cost, can be manipulated without much cost. So I think it's very important that the gestures are highly schematic. So let's talk about the first function. Gesture activates spatio-motoric representation that are already active. And so I'd like to distinguish two kinds of activation. One is boosting what's already there versus generating something completely new. So first study is about like boosting what's already there. And the second study is about generating new imagery that you wouldn't have generated otherwise. And so the first evidence is for boosting existing representation. So gesture boosts mental simulation of physical movements. Yeah. So in this study, we asked people to solve a problem like this. Gears are arranged in a horizontal line. If you turn the gear on the far left clockwise, to which direction will the gear on the far right turn when there are 4 gears? And participants didn't have this visual aid, so this is for your benefit. So people had to really imagine 4 gears in their head and solve this problem. And in this task, just about everybody gestures. So the kind of typical gesture you see is, okay, first one going to clockwise, second one this way, that way, this way. Okay, so it's anti-clockwise. So that's the kind of response you get from this. And what's interesting about this particular problem is that there are initially people manually simulate movements, but there's a more efficient way of actually solving this problem. If you solve this problem 4 or 5 times, you start to realize that actually I don't need to simulate. I just need to know whether there are even number of years or odd number of years. That's all you need to really know. But people usually don't realize that at the very beginning. So there are 2 ways of solving the problem: simulation versus sort of mathematical solution. And so our idea is that if gesture boosts activation of mental simulation, then with gesture, people should stick to the simulation strategy because it gives you the right answer. And if simulation is easy with your gesture, you should stick to it. Consequently, they should be less likely to find the parity strategy because you don't need to find that. So in this experiment, we manipulated whether or not people are allowed to gesture. So half the participants were prohibited from gesturing, so they were sitting on their hands to solve the problem. And the other half, we didn't tell them anything, but their hands are free and just about everybody gestured. And the key outcome variable is whether or not they found the parity strategy within 6 trials. And gesture has an impact on this. So here's the result. So y-axis is the proportion of participants. And we classified participants into 2 types of people. Green people found a parity strategy within 6 trials. Red people didn't. And left bar is the gesture allowed condition where just about everybody gestured. And the gesture prohibited condition is on the right-hand side. So green bar is higher in the prohibited. That means they were more likely to find the parity strategy. But on the left-hand side where people are gesturing, significantly more people just stuck to the simulation strategy. So red people just stuck to the simulation strategy. So what this means is that so the way we interpret this is that the gesture supported mental simulation of movement. Therefore, people stuck to that strategy. So this indicates that the gesture can boost imagery of object movements. And this had impact on the way they solve the problem. So I'd like to talk about another experiment in which supports the idea that the gesture can activate completely new imagery that you wouldn't have generated otherwise. And in this study, we look at the imagery that underlie linguistic metaphor. So metaphor is really useful because it helps us to understand abstract concept based on concrete spatio-motoric imagery. So if you think about the English phrase, spill the beans, so this phrase means disclose something confidential in English. And sorry. And so this is one of the English phrases that has metaphorical basis. So beans are pieces of information, and spilling is like giving information away to other people. So what we are interested in is whether gesturing help you lead to better metaphor processing. And we hypothesized that especially left-hand gestures are useful for metaphor processing because brain imaging studies and brain damage patient studies have shown that for metaphor processing, right hemisphere is really important. So we manipulated. So normally language processing is what left hemisphere does, but for metaphor processing, both hemispheres are very important. So we manipulated which hand is available for gesturing, and we looked at the quality of metaphor expansion. So And then we measure the quality of metaphor. And so the task is to explain the meaning and motivation for phrases like spill the beans. So beans are secrets. So the best answer is to say spill the beans means disclose secrets. Beans are like secrets, and spilling is like telling. And if a participant explain both mappings, then the participant gets 2 points. If the participant describes only one mapping, then they get 1 point. And if they cannot really describe the mapping, they get 0 points. Okay. Right. And in this study, participants were asked to keep one of the hands still. So right hand gesture condition of the left hand panel, the left hand, we asked them to keep the left hand still. And in the middle, left hand gesture condition, the right hand is now still. And then in no hand condition, people didn't produce. We asked them to just keep both hands on the surface. And if you look at the explanation quality, there's a significant difference between the three conditions. So y-axis is the quality, which goes the highest possible score is 2, and the lowest possible is 0. And left hand gesture, and what you can see here is that the left hand gesture condition is the best condition out of the 3. So there is a significant difference. Left hand gesture condition is significantly better than the no gesture condition in the middle, and the right hand gesture condition is somewhere in the middle. So, so what this shows is that the way we interpret this is that the left hand gesture condition stimulates the right hemisphere because left hand is innervated to the right hemisphere, contralateral hemisphere. So when you do sort of gesture with the left hand, that will generate imagery in the right hemisphere, which is important for the metaphor processing. That's why you can process metaphor better. So metaphor processing is better when producing left hand, especially for left hand gestures. And so left hand gesture activates spatio-motoric imagery in the right hemisphere, which is useful for the metaphor processing in the right hemisphere. So that means so this we take to be evidence that the gesture can actually generate imagery that you wouldn't have generated otherwise. That's why your metaphor explanation is better when you produce gestures. So gesture can activate new information, as in the metaphor experiment, as well as boosting existing imagery as well. So that was first function, first out of the 4 functions. Next one is gesture helps manipulate spatio-motoric representations. So when your task is to manipulate imagery, gesture can help. So so we investigated if gesture improves performance of mental rotation. So mental rotation is a kind of mentally rotating 3D object in your head. That's the task. And so, for example, if you have to solve this problem, you typically mentally rotate an object. So the task is to say whether the bottom object is the same as the top left or top right. So in order to solve problem, I hope that you have the sort of experience that you're trying to rotate the object at the bottom. And this task has been used by cognitive psychologists for many decades. And we tweaked the classical sort of task. And the key difference is that the people, so in the classical task, people use 2 hands to respond, right object, left object, by pressing a key. But we wanted people's hand to be free. So we asked people to respond with 2 foot pedals, right foot pedal, left foot pedal. And And participants were alone in the room, filled by a film camera. So there's really no communicative motivation to produce any gesture, but people do produce gesture in this task. And I'll show you a video example of that. So let me play this again. So I hope you can see that she's trying to like rotate the object that on the computer screen, even though nothing really moves. And that's what we call thought gesture, gesture that accompanies thinking. And so we had 3 groups of participants doing this task. In one group, we encourage them to gesture, please, use your hands to, while solving this problem. In the second, we didn't say anything about the hands. And the third group is gesture creative group where people are sitting on their hands. And the reason we encouraged one group of the first group of the people to gesture is that the gesture frequency is actually quite low, so people don't produce that much gesture. So we in order to have a clear contrast to see the impact of gesture, we have gesture prohibited condition and gesture encouraged condition. So in encouraged condition, people produce gesture every single try, or more or less. And people have fixed time for thinking. So error rate was the key measure. And our prediction was that the gesture encouraged group should perform the best. And that's what we found. So y-axis is the error rate. So the lower, the better. And the 3 groups, gesture encouraged group on the left, allowed group in the middle, and the prohibited group on the right. And so gesture encouraged group was significantly better than the other 2 groups. And with a follow-up analysis of the allowed group, if you compare the trials in which they happened to gesture versus trials in which they did not gesture, they perform better in the trials in which they happen to gesture. Okay. So even within the data from the allowed group, you see evidence that the gesturing is associated with better performance. So this indicates that the gesture helps to mentally manipulate spatial representation. So the third function is gesture packages information into units that are useful for speaking and thinking. And so evidence for packaging comes from description of motion events with manner path. And so this is the kind of stimuli we show to the participants. So triangle is jumping up the hill. And we manipulated what kind of gesture people would produce. So we, in one condition, we asked people to produce separate gesture for manner path. And in the other condition, we asked people to produce conflated single gesture for manner path. And the participants were Dutch speakers. In Dutch, the language, the grammar of Dutch is very similar to the grammar of English. You have a choice between the default is to produce express manner path in a single clause, but Dutch also has an option of using 2 separate clauses to express manner path. So what we measured was the syntactic structure people spontaneously used in the description. 1 clause versus 2 clauses. So 1 clause would be, he jumped up the hill. 2 clauses would be, he went up the hill and he was jumping. And what we see is that our gesture manipulation had a major impact on the kind of syntactic structure people use. So Y is the a proportion of responses, average proportion of responses. And if they use the 1 clause description, that's in blue. If they use 2 clause description, that's in red. And the left-hand side of the graph is a conflated gesture. condition where people are asked to produce a single gesture, then the description was predominantly one clause description, like a jump up. But when we ask them to produce two separate gestures, then they are more likely to produce two separate clauses, one for manner, one for path. So this indicates to us that the gesture can help us package information into units that are used for speaking. So when the gesture separate manner and path, then that unit was used for speech production, and people produced two separate clauses in the speech in the description. So here's the final, the fourth function of gesture, which is a gesture exploration of conceptual world. So when solving a problem, one needs to select the information that's useful for what you're doing among many pieces of information that could be relevant. And our idea is that the gesture can help explore information that could be useful for speaking or thinking. And so one sort of probably the sort of the best evidence for this kind of a function is how gesture can influence creativity tasks, so-called creativity tasks. So when psychology, so this is one of the tasks that psychologists often use to test creativity. So list all non-conventional uses of newspaper, for example. So you can say things like, you can use that as a blanket when it's cold, or you can roll it up and whack flies or something like that, or mosquitoes. So these are sort of non-conventional uses of newspaper. And Kirk and Lewis, so this is not my work, but Kirk and Lewis has found that the people actually generate more ideas when they are allowed to gesture, as opposed to when they are prohibited from gesturing in this kind of task. So people are more creative when they're allowed to gesture. Okay. And that's because gesture can kind of explore, what's possible with this, object, and you can generate more ideas. So you can explore what's possible more efficiently with gesture. So gesture helps explore spatio-motoric representation via trial and so I'd like to sort of summarize for functions. So we looked at gesture activation, function, manipulation, packaging, and exploration. And gesture affects our conceptualization that's necessary. The way we kind of capture the world. That's what I mean by conceptualization. And we have to conceptualize the world in a particular way for thinking and speaking, and gesture has impact on that. And and I think that the gesture has these kind of cognitive functions because gesture is schematic. Gesture reduces information to the essentials. So this rolling down, going down the hill can be just, depicted by this sweep of hand in front of me, in front of the body. So reducing information into the essential, and that kind of lightweight representation is easy to activate, manipulate, package, and explore, and also just focusing on the essentials might also help you to generalize the knowledge to new contexts as well. So I talked about many different studies, many different results. I'd like to summarize what we saw today. So we looked at mechanism and functions of gesture. And so in terms of mechanism, we saw our study showed that the gestures are generated from the same module as the practical action. And also, but at the same time, gesture is influenced by speech formulation process. So grammatical difference across 3 languages had impact on the way people gesture, Japanese, Turkish, and English comparison. In terms of function, gestures can activate imagery that's already there, or it can activate something new, which is the metaphor study on the right. Gesture can manipulate your imagery, and gesture can package information that into the units that's going to be used for your speaking task or thinking task. And also gesture can help you explore what's out there in your conceptual world. So and because gesture representation is a schematic, it helps you to focus. It's lightweight and flexible, so you can manipulate it in the way you want. So looking at these sort of functions of gestures, you can see that the linguistic communication, gesture really plays an important role in linguistic communication because it actually influences the, how your kind of grammatical structure you might use, for example, or how good your metaphorical, your explanation for metaphorical expressions are. Gesture can have impact on that. And also, gesture can have impact on cognition. So if you want to really understand cognition, you need to actually pay attention to gesture. Right. And I think spatio-motoric thinking sort of complements verbal thinking. So the take-home message is that the gesture generated at the interface of action and language shapes the way we think and we speak. And that's all I'd like to say today. Thank you very much.